And that's it. Just to, and it started. Okay, that's great. As always, your questions are always important to us. So please put your questions, and I know some people already have. Put some comments in the chat room. We're over 12 months now into these video calls, so most of us on the call today will be used to and experienced of this. So please put your questions in. Managing Director for CeeD will be overseeing the questions and answers later on in the morning. Just to give you a bit of background, 2 minutes or 1 minute of CeeD. CeeD's a peer-to-peer membership organisation, non-for-profit, that looks to bring in amount of knowledge to our session. I'm just wondering if we could close the microphones off. If I could, just 1 moment. I've got to try to find out where to. Okay, we'll carry on. Peer-to-peer organisation. If you look at the fact that there is 106 people on the call this morning and an immense amount of knowledge that's in the room, how do we tap into that knowledge to share best practice and knowledge around the different sectors, the different companies that we have? It's a fantastic opportunity for us to get to bring in that knowledge, that peer-to-peer exchange. At CeeD, we like to try to connect people to help with operational issues that they have. We're very conscious of some of our members' operational issues, so therefore we look to go to the membership to ask the question, can you help? And so our offer of help along the way is there. We're connected with the Advanced Manufacturing Hub of the 12 projects that's around the country. That's a 3-year project that the Scottish Government through Scottish Enterprise developed. We have secured that for 3 years. We're 1 year into it, so we're 2 more years of that. And my new colleague, Patrick McCarthy, who's on another video call this morning, is the program manager, and Jane Findlay, who's on the call this morning, is the marketing manager. So we've increased our presence to 6 members of staff at CeeD, and one of which, my new colleague Lauren, who is joined us a few months ago, is actually dealing with an event that is relating to low carbon energy on the 27th of May, and that's on our CeeD calendar. That's a great opportunity for circular economy, and it builds in with our event today. So we're always looking to showcase events and event member companies, so that's fantastic. So without further ado, very conscious of time, I'm going to introduce Nigel Holmes, the CEO of Scottish Hydrogen and Fuel Cell Association. Nigel's going to share his screen and talk about what is happening to hydrogen, the major trends and opportunities. So over to you, Nigel.
Hey, thank you very much for the introduction. And if the technology works, I will get my screen up and we can start to go through the slides. Good. So, Dave, is that all clear?
Yes, so, that works perfectly.
Excellent, excellent. So, I'm going to just be going through some of the trends and the opportunities that are happening with hydrogen, specifically talking about the projects that are happening now in Scotland, and also to give you a sense of where things might be going next. And I'm going to mention Port of Cromarty Firth, but I'm going to leave that very much to the next speakers to actually flesh out the details and give you a sense of the opportunity and the scale for Port of Cromarty Firth. And I think it's fair to say that many of the projects in Scotland, we are learning from each other in terms of what we do. And we're also linking into other projects around Europe. Many of these are taking some of the ideas from Scotland and actually scaling up. And as a key part of that, CeeD is obviously bringing together people from across Scotland with many different areas of interest. The Scottish Hydrogen Fuel Cell Association, we're targeting the activities with hydrogen fuel cells, basically what it says on the tin. So many of the speakers today are actually from the association, and if you want to find out more, please do get in touch with me at any time. So where do we start from? Well, the key thing here is net zero, and a lot of the work that is happening now is about delivering the net zero targets. Scotland's got a target for net zero by 2045, but I would suggest the really important one now is the 2030 target, which is a 75% reduction in greenhouse gas emissions by 2030. And to put that in context, the European Union recently set their target, a 55% target by 2030. But as you can see later on, the targets could actually be complementary. So within Scotland, we've seen a great increase in the amount of renewable energy being produced, to the point now where Scotland's annual electricity demand is pretty much met from renewables. It was, I think, 97% of Scotland's electricity last year was met from production of renewables in Scotland. But we don't stop there. We go beyond 100%, and then the opportunity is very much about how we start to produce the green hydrogen from renewable electricity. And this is using the electrolysis of water with electricity to produce hydrogen and oxygen. And the hydrogen is what we want. This is the
Nigel, you've muted yourself.
I don't know how that happened. I must have been getting too excited. Anyway, let's hope it doesn't mute itself again. So the journey around Scotland, we're going to take in Aberdeen, Fife, Orkney, and then touch briefly on Cromarty before we look at the wider context. So starting in Fife, 10 years ago, the Hydrogen Office in Fife was opened. Since then, it's done some fantastic work in terms of building up the appreciation of hydrogen as part of the energy system. The education and outreach has reached out to some 35,000 pupils and students in Methil and across Fife. And the reason that's important is because the next steps in Methil are going to be very much about how we start to deploy hydrogen in households, hydrogen for heat. And Colin will probably touch on this later. It's the SGN H100 Fife project, using green hydrogen produced from offshore wind and taking that, distributing it around Methil and giving householders the option to use hydrogen instead of natural gas for domestic heating. So as I say, Colin will probably pick up on this one later on. But the key thing here is, why use hydrogen? Why not just use electrification? And this comes back to, when it's cold, we all tend to put the heating on. And that means there's a lot of demand for the heat, and the amount of demand in the winter for energy for heating is about 6 times more than that in the summer. And at certain times of the day, it can be even more than that. So in the cold mornings, when you put your heating on, if everybody does the same, there is an awesome amount of energy needed for that heat. So it's about supplying that heat securely, low carbon, all of the time. Anyway, moving up to Aberdeen. Aberdeen, the focus there has been more on the transport. The deployment of the hydrogen fuel cell buses in Aberdeen has actually allowed them to build up not just the buses, but a whole fleet of about 65 hydrogen vehicles. That includes buses, trucks, vans, cars. And this has given Aberdeen a lot of experience in not just the vehicles, but also the refueling. And this refueler here, we think it's actually the most intensely used refueling station in Europe. It's been dispensing about 35 tons of hydrogen per year since 2015. The buses have done 1 million miles, carried a couple of million passengers, and it's been exceptionally reliable. And this is important. If you've only got 1 or 2 refuelers, you need to make sure they're running all of the time. And as well as the buses, there's got the Mirai, the Toyota Mirai fuel cell car. But importantly, this has been put into a city car club application where anybody in Aberdeen with a driving license can actually use this Mirai. You just need to book it up and then take it out and experience the fuel cell comfort and low emissions. But going forward, although fuel cells will play a massive part in delivering net zero, we also think that the use of hydrogen combustion engines could be a very important approach, especially for heavy duty applications such as marine. And this CMB Hydrocat is an example of one of the boats that's coming through at the moment. Ideal for work boats, 1,000 horsepower engines running on hydrogen, use a couple of 100 kilos of hydrogen a day, but it's displacing a lot of fossil fuel. And going forward, Aberdeen very much as the hub for not just offshore wind, green hydrogen, but also looking at the production of hydrogen from natural gas, but using carbon capture and storage. So this is the Acorn project, how you can actually produce that hydrogen with a low carbon footprint, but then you're not relying on the wind. So it gives an extra level of security to the supply of hydrogen, especially in the early years when we're scaling up, wanting to scale up quickly. And this comes into some of the wider issues of when we start to scale up, can there actually be an opportunity to link into wider networks, wider demand for hydrogen? And some of the work in Europe is very much about starting to connect the European countries together using the hydrogen backbone. This is the Hydrogen Europe study that came out about a year ago. And when you start to look at more recent work, looking at the supply and demand for hydrogen across Europe, you can see the opportunity for Scotland. Green means you've got plenty of renewables. You could start to produce hydrogen. Red means you're in deficit. To move green hydrogen, blue hydrogen, or low carbon energy from Scotland into Central Europe, where they need it to meet their targets. But moving now up to Orkney, and this is very much a location that is several years ahead of the curve in terms of the deployment of renewable electricity. They've been self-sufficient in renewable electricity for about 5 years, but that brings its own challenges. One of them is that sometimes the wind turbines produce more electricity than is needed locally. And the opportunity here has been to actually take the hydrogen from where it's being produced on some of the islands, so Edy and Chappensea, and move it down to the mainland of Orkney. And this is being moved by ferry.
You've got replacement gauges coming up.
Taking the
They're
example
being
on
dispatched to us
Chappensea,
tomorrow.
could you mute your microphone,
So they'll
please? You're
probably
now
be here
on live as well.
Thursday.
So you start
Does
on
it want to wait
Chappensea,
till then, or do you need to
and
keep
the
moving?
electricity from the wind
System.
turbine is used to produce the hydrogen. That can then be used on the island or moved down to Kirkwall, where it's actually being used for various applications, transport, heat and power, and moving forward, they've got some very interesting approaches in terms of other transport applications. But the lessons from Orkney have been applied to other countries. So the North Netherlands, the Heaven project is a much larger project, but uses the same principles of building up hydrogen supply, hydrogen demand with the infrastructure. And also on the island of Mallorca, the Green Highland project, producing the electricity from solar rather than wind, as you might expect, are actually looking at using a pipeline to move the green hydrogen from where it's produced down to the city of Palma. And there it will be used for heat and for transport applications. So very much about building up the supply and demand. Further information about the approach is available through the Hydrogen Territories platform. And if you're interested, just log onto the website and you can log to get more information in from the HTP. So what next? Well, it's very much about some of the innovative projects. I mentioned Orkney's interest in other forms of transport. They've been involved in the High Flyer project, the single engine hydrogen fuel cell plane that you see on the left. And the project Fresson, that is actually converting a Britain Islander into a hydrogen plane. And those planes are actually used in Orkney. This is Kirkwall Airport, which is now the Sustainable Aviation Test Hub. And the plane that you can see on the tarmac just in front of the shed, that is one of the Britain Islanders. I don't think it's the one they'll be converting. It's still in use at the moment. But it's just to say that Orkney is also looking at other approaches. And scaling up, this is where Cromarty gets very interesting as an opportunity for scaling up. You'll be hearing more about this later. just to say that the whole idea of the hub is building up supply, the infrastructure, and the demand. Take any one of those away, and it gets very difficult to make it work properly. And the opportunity for Scotland goes beyond Orkney, it goes beyond Cromarty. The North Sea has got a fantastic resource for offshore wind. It's estimated that in the Scottish part of the North Sea, there's something like 735 gigawatts of offshore wind potential. We've just started. It's a long journey, but it's going to be a massive transformation, essentially displacing the production of oil and gas from the North Sea by production of renewable energy. And this has been recognised by the Scottish Government. The hydrogen policy statement came out in December last year with a target of 5 gigawatts of low carbon hydrogen by 2030, and then scaling up further for 2045. But it's not just about local demand, it also sees the potential for international export markets and also providing other areas around the UK with low carbon hydrogen. And this comes back to essentially the opportunity. Scotland is in a fantastic place with renewables. It can start to build on the projects that have happened already, scale up the production of green hydrogen and blue hydrogen, and then start to supply low carbon hydrogen, low carbon energy into markets such as Central Europe, which have an ongoing need for that supply and don't have the same access to renewables. Going forward, great opportunity coming up later this year in Glasgow in COP26, November. Hope you can make it along to that. I'm sure it will be busy. It's now been confirmed that it will be an actual in-person event. And that very much is the opportunity for Scotland, scaling up hydrogen, scaling up the use of renewables and using it to decarbonise Scotland and taking it forward, decarbonising, helping to decarbonise other countries and the whole of Europe. Dave, that's very much my presentation, and I'm going to stop sharing now and hand back to yourself for the rest of the event.
Thank you very much, Nigel. That's much appreciated. Just to let everybody know on the call today that the PDF of all the slides will be sent out at some next couple of days. So just to let everybody know. Right, we'll move swiftly on to Martin Tulloch, Head of Energy Systems Integration at Ogtc. He's going to talk us through technology driving transition. So over to you.
Thanks, David, and good morning, everyone. A quick introduction to Ogtc. Initially, we're a relatively young organisation. We're established in 2017. We're funded by both the UK and Scottish governments through the Aberdeen City and Shire deal. We're very much a partnership and a membership organisation, so we work with industry, everyone from the large oil and gas operators, the Shells and the BPs, all the way down to small technology developers. So everything that we do is done in partnership with industry, and you can see that from our investment history. So to date, we've invested £163 million, and over £100 million of that has been leveraged in from industry. So that's right at the heart of everything we do. We only invest in projects where there's industry demand. In terms of the track record, we've invested in over 260 projects from a hopper of over 1,200. One of the key things is that we've got a number of these projects into field trials. So we've had over 60 field trials complete and 40 either planned or underway. And that's quite important if you're a small technology developer, is getting your technology in front of the end customer. In terms of our strategy, we've got 3 focus areas. We want to decarbonise the existing oil and gas industry, but we also want to look at the growth industries of hydrogen, of carbon capture and storage, and of offshore renewables. And then we've got a third programme looking at offshore energy 4.0. So that is digital technology, anything that can automate processes, software, all the smart stuff. Given the audience, I thought I'd start with this slide here. Magnus in the early 80s being towed out, still the largest steel jacket to be deployed in the UK North Sea. This one slightly larger in the Norwegian sector, but a tremendous feat of engineering achievement. And to me, it's a real reminder of what we can achieve as a country, both in terms of the design and the manufacturing capability that we have. The image on the right is one that just always blows my mind whenever I see it, of Magnus alongside Big Ben. I've been on Magnus a few times, and you don't really get the scale of what's under the water from sitting up there on the top sides, but it's a truly colossal structure. We look at the workforce that we had in the Cromarty Firth back in the boom days of the 70s and 80s. probably averaged around 2,000 people at NIG alone. You had a large workforce at Ardusir. You had the Kishorn workforce. You had the BIFAB, well, the Firth of Forth workforce. And to me, that is the real prize in the energy transition. If you look at the scale of capital expenditure that we need to deploy as a country, indeed as a continent or across the globe, it's colossal. So the manufacturing opportunity is tremendous in loads of sectors. But one thing I want to just highlight briefly is that it will be a different manufacturing experience. It'll be much more production line focused, automated. This is a still from NEL's latest investor presentation. It shows their alkaline production facility at, I can't remember the name of the place, but not far from Stavanger. So similar to Cromarty Firth, similar to Aberdeen, great oil and gas heritage. But this is very much the new industry that we're hopefully going to be part of in the near future. If you look at the assembly line here, you've got a bottom right, you've got the factory test and then completion sector, and you've got pretty much components coming in the left, flowing through the system, and then everything being tested and deployed at the right-hand side. Now, something that I want to get across today is that if you look at the hydrogen sector, it quite often looks like a school chemistry lesson. You've got an image like this that shows that the basics of water electrolysis. So you've basically got two electrodes, an anode and a cathode, separated by an electrolyte, either a solid or a liquid. So the sort of the basic, the oldest form is alkaline electrolysis, which is not compatible with intermittent renewables. So in the mid-60s, GE was actually the first country to introduce PEM, the first company to introduce PEM electrolyzers. They are much more dynamic. They can work with intermittent renewables. More expensive at the moment because there's sort of precious metals involved in manufacturing them. But that is ultimately the future for green hydrogen production in Scotland. Now, if you look at what that looks like in real life, this is a still from Siemens. Now, Siemens is a partner of Ogtc, a company that we've developed quite close links with. This is their Sillizer electrolyzer technology. So it's modular. It can be deployed up to 17.5 megawatts at the moment. They're currently scaling that up to 30 megawatt units. In terms of scale, it's roughly the size of 3 40-foot shipping containers. So large, but not mind-blowingly large. It can produce 330 kilograms of hydrogen an hour. It's got a fast ramp-up rate, so you can basically ramp up from 0 to full production in less than a minute. It consumes 10 liters of water for each kilogram of hydrogen produced. So you do need quite a significant water supply. And that leads me on to the next point I want to make, is that there's more to electrolysis than purely electrolyzers. So this image here, again from a Siemens presentation, shows you the what's involved from end to end. You've got water treatment at the front end to get it to a level of purity that can be used by an electrolyzer. You've got gas purification coming out. You've got compression. And compression alone is a niche I think the engineering sector has got to spend more effort on. There's real opportunities there. If you look at existing compressor technology, you can probably use existing compressors with a blend of up to roughly 10% hydrogen without any modification. When you get beyond that, between 10 and 40%, if you change some of the impellers and adjust some of the gearing, you can still use existing technology. But when you get beyond about 40-50% hydrogen blend, you need to replace the compressor. And there's some quite significant modifications that need to be made. And hydrogen's got a lower molecular weight, so you need to increase the speed of the compressor to get the same transport of energy. So a lot of challenges that we're starting to look at in Ogtc along with our partners there. Storage and transportation, again, can we reuse the existing gas network? What modifications do we need to make? Storage, are we going to use ammonia? Are we going to use LOHC? Is it going to be compressed? There's a lot of technology challenges, but also engineering opportunities in there. And this is just another slide that I think helps illustrate the potential supply chain opportunity. So it's from an NEL presentation, and they show in purple the scopes that they see as internal to their business model, and everything on the right side is going to be outsourced to EPC partners. So you've got HVAC, you've got electrical work, you've got civils works, a whole host of things that the oil and gas supply chain, that the civil supply chain can get involved in. And we as an industry need to start doing the business development work to get some of these opportunities and to build the partnerships with companies to be able to deliver the scale of project that we need to develop. Now, the same happens in blue hydrogen. So we quite often look at that as a chemistry lesson as well. You can see here the sort of block diagram for basic steam methane reformation. So you've got natural gas coming in the left. You've got a pre-feed stage. It's got to be purified to remove any sulfurous compounds. That's crucial to prevent poisoning the catalyst in the SMR unit itself. So SMR is basically a high temperature process where you use steam to split the hydrogen from the methane gas. You end up with a sign gas, which has then got to go through the shift conversion and the carbon capture process to get it to a sort of purity where it can be used. And what does that look like in real life? And this is a great image here from an Air Products presentation. So you see the natural gas coming in bottom left. It goes through the sulfur removal process, through the steam methane reformer, which is a huge structure itself. You can see the scale compared to some of the people that are down there in the ground level. So a lot of piping, a lot of process equipment involved in this. You see the water gas shift reactor coming out the back end there. You see this sort of PSA carbon capture technology, and then ultimately ending into the gas network. And looking at that in real life, this is a unit that Air Liquide commissioned earlier this year. So 82 million euros of construction cost, over 400,000 person hours, so a significant project, producing over 50,000 cubes of hydrogen each hour. And that is the sort of project that the oil and gas supply chain has delivered in different guises all over the world. And there's a huge opportunity for us to look at this in the UK. And I think Sam will be touching on this on the pale blue dot presentation later on. I want to finish briefly. I want to try and stick to my time with a short personal story. I mentioned Magnus at the start. Back in 2005, I was engineering manager on the Magnus Extension project, so the biggest brownfield project in the North Sea at the time. We're installing 4 new conductor slots on the outside of the jacket, lots of topsides modifications, lots of subsea work. We had a team of engineers, the usual disciplines: mechanical, piping, structural, electrical, process, tech, safety, instrumentation. And later in 2005, I moved for 2 years to the Outer Hebrides. I took a post with the local authority. One of the projects that we delivered there was a hydrogen station. So just quite a bog standard piece of kit: electrolyzer through storage, through compression, through pre-cooling into the dispenser. But the thing that I learned from this project was the skill set that was involved in oil and gas was a very similar skill set that was needed to deliver this, albeit a small scale project. And that's equally applicable when you look at the gigawatt scale projects that we need to get to, but just on a much larger scale. So I will stop there. I think I hand over next to Ed and Joanne, and I just look forward to taking your questions at the back end of this session.
Thank you very much, Martin. Yes, over to Ed McFarlane, Principal Consultant for Abbott Risk Consulting Limited, who's going to take us through an introduction to the high-level safety areas of hydrogen. Over to you, Ed.
Okay. Morning all. So as Nick said, this is very much an introduction. It's a fast run through of hydrogen safety. And really this is just to give you the first sort of jump off points to go and get additional information. I've embedded quite a few hyperlinks in the presentation, which will be provided after the webinar. So please don't feel you have to make notes. It will be available. I hope that will give you a good lead into where we need to go. I'm going to very quickly just run through the hydrogen technologies and the applications, because that will give us an idea of then what safety considerations come off the back of that. So a high-level summary of some of the principal legislation, very much focused on the UK, but just to give you a few touch points, and also just some high-level kind of considerations that affect safety considerations, and then some additional resources. As Martin said, although everyone seems to focus on the individual bits of technology, we do need to take a kind of whole systems approach. So that's not just the technology, but also how we manage, how you resource, and how you have, for example, appropriately qualified and trained maintainers for your system through life. So just to summarize broadly what hydrogen technologies are considered, and Martin covered quite a few of them in his presentation. So I'll go through basically production, storage and transport, and actual application. Now, it's really important to emphasize here that hydrogen is not a new material. It's been used in the world for a long time, but it's really been very much at the kind of very small scale, high quality hydrogen for sort of scientific applications through to very large scale process industry. And what we're finding is that the real area of change is in where it is applied, where hydrogen is applied in the different sectors, and that's where some of the challenges arise. But just to quickly run through the broad sort of technologies that are being used in the current hydrogen sector and the emerging hydrogen sector. So, as Martin mentioned, steam methane reformation, combined with combined with carbon capture, utilization and storage, which Sam will talk about later. And it's often called blue hydrogen. Electrolysis of water, and two broad technologies there. One is PEM, as mentioned before, and alkali electrolyzers. Both have different areas of application and have different pros and cons to their use. There are other methods for producing hydrogen, but far and away, those two methods, either SMR or electrolysis, are far and away the dominant means of producing hydrogen. And there's a link there to the US Energy Information Administration to provide some additional information. Broadly, kind of storage and transport is in a number of different forms. Broadly, it splits down to these four, which is gaseous compressed hydrogen, liquid hydrogen, which is compressed and chilled, ammonia, and then this broad category of what are called liquid or organic hydrogen carriers, toluene being an example. And these are almost like hemoglobin in blood. They can take on hydrogen and then release it again at a later date. But those are the four broad technologies. And probably another one that's worth mentioning is what are called metal hydrides. So these are a metal matrix that can absorb, act in a very similar way to the liquid or organic hydrogen carriers, but is metal-based, but very similar approach. In terms of application, there's a number of applications, but again, what we're finding is you need to look at, it's not just the hydrogen part, so the hydrogen fuel cell, the hydrogen storage. There's combined systems in each of these areas of application, but these are the broad areas of kind of new application. So stationary power storage, predominantly we're seeing compressed hydrogen with a fuel cell, where the hydrogen is then run back over the fuel cell to provide electricity. Road transport, and two broad categories of system here. We have direct injection of hydrogen into an internal combustion engine, so replacing it some or all of the fossil hydrocarbon that is used as a fuel. Or the other approach is akin to an electric system. So we have hydrogen storage, a fuel cell, often some sort of battery or capacitor, and then ultimately to an electric motor. And this kind of configuration of hydrogen, fuel cell, some sort of high peak power demand, energy storage system, the battery capacitor and electric motor is quite a common emerging configuration we're seeing across a number of sectors. So rail transport, still very much in the research and development phase, although has been a deployment in Germany of a hydrogen rail. It's still very much learning, and the sector is still very much learning. But again, it's normally more the electric drivetrain, so hydrogen, fuel cell, battery capacitor, and electric motor. Aviation, broadly, this is falling again two categories. So direct combustion in a gas turbine, or again, this electric kind of powertrain configuration. Marine sector, again, we have this direct combustion, but here the marine sector is focusing or has given strong indications they're looking at ammonia for direct combustion in a gas turbine, or hydrogen fuel cell and battery capacitor. And finally, heat. So either we've got direct combustion, and for a lot of industrial processes, this is being looked at. They need really high intensity heat. Direct combustion of hydrogen is being looked at. But another approach for sort of domestic heating is what's called a catalytic flameless combustion. So this is where you flow hydrogen across a catalyst, combine it with oxygen, often well below the flammability point of hydrogen and oxygen normally. But this produces this flameless heat, which can then be used as part of a normal sort of boiler or heating system. But, and this is still really important to think about, far and away the biggest use of hydrogen in the world currently and for the foreseeable is as chemical feedstock. So in refining or in ammonia production, it is still, and for very much the foreseeable, will be the biggest demand. And that's where, for example, the diagram that Nigel put up, you'll see that one of the areas that has the greatest demand is sort of northwest Germany, and that is very much the chemical feedstock sector, and that's the use of it. So all those applications, none of them are particularly new, and of course there's relevant legislation, and all relevant safety legislation that applies to flammable gases and pressurized gas systems will still be applicable. So the list I'm about to currently do is not a complete list. This is just to give you some touch points to look at, but here's some general points around it. So legislation, standards and guidance are developing in parallel to the deployments. The sector is learning by doing. So we are learning an awful lot of application and lessons learned and trying to iterate quickly. Just working to the standard or best practice isn't really a viable approach, because we don't yet know really what the baseline for best practice is in a lot of these areas of application. It probably works for some very simple systems, and there's obviously certified pieces of kit. So if you really are just applying a single item of kit, it probably is a viable approach. But for most practical systems that have been deployed, it really isn't it isn't practicable to work to this, just work to the standard. You need to be a bit more considerate about it. In a number of sectors and areas of application, specific standards for hydrogen systems may not exist. And so considered use of nearest comparable sector is a frequent approach. You need to be aware of other sectors. You can't just focus narrowly on your sector. And so broadly, there's kind of three sort of really large, high level kind of categories within the UK. And this is very much the UK onshore. Up to 2 tons of hydrogen is below the hazardous planning limit. Once you get above 2 tons, you're into the hazardous planning limit, and you have a lot more oversight from like county council and the HSE. And once you hit 5 tons of stored hydrogen, you're into the lower tier COMA limit. And then the next level up there is the 50-ton upper tier COMA limit. And again, just to reiterate, all appropriate general health and safety working legislation will still apply. But broadly speaking, you're going into increasing levels of oversight and review and depth of assessment you need to do. So in the UK, please, this is not a complete list and would need to be reviewed for specific applications, and make sure that you're working to the most current updates and versions. This is just a representative sample. So broadly, we're talking about pressurized gas and pressure system regulations, but also transportable. We're talking about flammable and exposed materials, so DESIR and equipment and protective systems for use in exposed atmosphere are all going to be relevant. Depending on the specific application, we may well be into COSH. So, for example, the use of alkali electrolyzers, you may well have to consider it, or metal hydrides. So you do need to be aware of this, but also REACH as well might well be applicable. And of course, if we're planning to move hydrogen around, there's a whole load of legislation around the transport and regulation of goods, both on the road and also in harbours and marine application. So some specific kind of challenges around the characteristic of hydrogen in comparison with other flammable gases, which members might be aware of. So it's low density. Most practical systems are operating in the 350 to 750 bar range. This is a much higher pressure than most other flammable gas systems, and you need to be aware, therefore, of the high pressure risks as well. Hydrogen has very low viscosity. It is going to leak. It is, if there is a crack or a slight breach across any sort of gasket, you will almost definitely have a leak of some sort. It has high diffusivity, can migrate through a volume very quickly and through materials. And related to that, we have this issue of embrittlement. So it can affect materials that it's contained or transferred in. It has very high buoyancy. We, of course, all know the Hindenburg, but this can work to your benefit in that any release is going to diffuse very quickly, but don't assume that it will do. Because we have a high pressure release, that can have a huge amount of momentum, and actually a jet can stay quite low to the ground or quite low to level with the point of release, but it will eventually diffuse and diffuse away. It has a very wide flammability range, far more than other flammable gases, and a very low ignition energy. It's probably going to ignite, and really the question is just a matter of whether it is a delayed ignition or an immediate ignition on the leak. Related to that, has an invisible flame. It's not really visible in daylight. It burns high in the UV range, but there is an advantage to that in that it doesn't radiate that much heat. And also because it's also related to this rapid burning rate. You tend not to get the same sort of thermal load you'd get from a hydrocarbon fire or explosion. But the concern with this rapid burning rate is that the ignition, where you get deflagration, can transition to what's called detonation. So deflagration to detonation transition, DDT. And this is where you get very high impulse loads from any delayed ignition of a gas cloud. And what you really need to try and avoid is congestion and confinement. And as we're probably going to be talking about liquid hydrogen, you do need to be aware of the cryogenic hazards. And with liquid hydrogen, there's a real concern is that it can actually condense out oxygen from the atmosphere, and you can end up with a mix, a slurry of kind of water ice, liquid hydrogen, and liquid oxygen, which obviously has fairly significant explosion and detonation risks. So broad kind of lessons learned is there's plenty of standards for individual items of kit or components, but as Martin alluded to in his presentation, you do need to have this consideration of a whole system approach and the integration of the components and kit and how they will be operated to maintain. How you manage your system is going to be really, really important. There are some fairly significant supply chain challenges that do kind of impact safety. Installers and maintainers are sparse and often based in geographical locations remote from where the systems are deployed. We have an awful lot of these small deployments that are spread out and often remotely monitored. And as much as Martin was quite right in saying that we can transfer our skills from other sectors, there's an awful lot of relevant experience, but you do need to be considered about how you do that transfer and make sure that people are aware of the difference between the different systems. Now, all of this is really coming down to this. So this is an accident that happened in Korea, South Korea, sort of around this time in 2019. Very significant accident. The immediate cause was there was it's a research and development park, and they were testing electrolyzers, PEM electrolyzers, and they ended up with cross-contamination of oxygen into the hydrogen stream with a mix, resulting in a mix of oxygen and hydrogen storage, internal static ignition, and this congestion and confinement, which I mentioned before, resulted in effectively what was a bomb. So you can see the storage tank above. It detonated, killed 2 people, 5 very serious injuries, and very significant property damage. The immediate proximate causes there was a number of items weren't installed properly on the system, but again, we need to take this wider systems approach. There was safety management failures at multiple levels and multiple organizations. There was ongoing pressure to complete the testing, and perhaps there was this view that because it was a research and development or a demonstrator project, that it didn't need the same level of safety assurance. You need to be really cautious of this kind of safety culture and this kind of assumptions around what we're deploying. So here's a summary of a number of relevant standards. Please don't think you need to note this down. These are the hydrogen-specific ones, but there's a huge number of other applicable standards, obviously relating to materials and flammable gas systems that are relevant. This link at the bottom, although it's based in the US, they actually maintain a kind of ongoing international review of legislation, or codes, as they call it in the States, codes and applicable standards. It's a really useful resource. You can go there, and it has a whole number of standards and guidance broken down per sector as well. So a really useful resource. Please go and use that and look at your specific sector. The HSE is obviously doing a huge amount of work, and the Health and Safety Laboratory, who've been doing quite a lot with SGN. These are all hyperlinks, and there's a number of research reports which the HSE publish. Please use the HSE. There's a huge amount and depth of information there. Hopefully this gives you a shortcut to a number of the most relevant ones for hydrogen. But please go and have a look, and there's some more general pages there we can look at. This Safe Net Zero seminar, which was run earlier this year, was fantastic. All the presentations are still available and up. Please go and look at it and familiarize yourself with it. It's really useful. And then there's a whole host of additional resources here. So British Compressed Gases Association, also Gas Association, ECGA, Hydrogen Europe, huge number of projects and depth of resource there as well. High response. Now this is specifically targeted at first responders to hydrogen incidents and accidents. But again, it's got some very good primers on hydrogen technology and its behavior. The HEA, who I mentioned previously. They have a really good website outside just the codes and standards that they monitor. Again, a huge amount of resource focused on the US, but really useful. International Association of Hydrogen Safety, there's the two links, one to the conference and one to the generic page. Fuel Cell Hydrogen Europe, FCHJU, really lots of useful. Shifka, Nigel, so please go and look at the Shifka website. Nigel's a great contact. There's the High Law online database, which gives you a whole lot of information around the different legal and a fantastic searchable database about different codes and standards within Europe primarily, but really good if you're working on projects across Europe. And finally, a link to a paper from one of the HySafe conferences, an introduction to hydrogen safety engineering, which gives a really good rundown of an overall hydrogen safety engineering process. And I'll stop there, David.
That's brilliant. Thank you very much, Ed. And I know you'll be got another session in a few minutes' time. Over to Colin Thompson, Energy Futures Manager with Scottish Gas Network. He's going to talk us through to the journey of Scottish Gas and their transition to the gas grid to hydrogen. So over to you, Colin.
Thanks, David. Yep. Morning, everyone. I've got a presentation. I'll just get that up and running. I'll turn my video off. Hopefully you can see that now.
Not quite yet, Colin.
Oh, hold on a second.
It's just starting to come up.
How's that? Yep.
That's perfect. Just need to go on presentation mode.
Yep. Hopefully that's presentation mode now.
Perfect.
Okay, thanks, David. Yeah, good morning. Yeah, Colin Thompson from SGN. Yeah, I've got a few slides I'll run through. Some of them I'll skip quite quickly because other presenters have actually spoken about the topic. So I'll just quickly go through these. So yeah, a little bit about SGN first. We are the owner and operator of the gas distribution network in Scotland. And the south and southeast of England. We also have a small network in Northern Ireland that we own and operate as well. So we distribute gas to approximately 5.9 million meter points, which is about 75,000 kilometres of gas network that we own and operate. We carry out the emergency service. So if somebody smells gas, we come out and look at that and repair it in our patch. We are also replacing approximately 1,000 kilometres of old cast iron pipe work each year, and we're replacing that with polyethylene pipe, which is actually safe to transport hydrogen in. So that's been carried out on an annual basis up until 2032, and we also provide a connection service for new properties, new industrial, commercial consumers connecting to our network. So a little bit about the policy landscape and what's changing. We've had various targets now from both UK and Scottish government. Nigel mentioned these as well. From a network perspective, we're predominantly waiting on heat policy decisions that will come from the UK government in 2025 is our expectation. There's been various other policy documents issued recently, either from the Committee on Climate Change, the government's 10-point plan, base white papers, but also the Scottish government and their ambitions for decarbonisation with the 2045 target, but also the 2030 target with a 75% reduction in emissions. And the Scottish government have been very active with their heat and hydrogen policy statements as well, both last year and expectation this year for new statements coming out. Nigel touched on this, the challenge of certainly around heat decarbonisation. Gas predominantly supplies 85% of properties in the UK as it stands. Is slightly less in Scotland, but it's a massive challenge, and you can see there the difference between the gas and the electricity networks on the left and the right hand side, and just the scale of the energy from gas that's used during those peak periods during the winter, whereas the electricity is relatively flat profile throughout the year. So there is a massive challenge there, and it's not just on a seasonal basis, it's also within day and indeed down to some of the within minute demand profile for gas, which has greater flexibility as it stands than electricity to meet demand. And at times it can be 8 to 10 times as much energy that's used within the gas network than there is within electricity. Well, that's not to say there isn't a place for electricity and heat. I think gas offers an opportunity for the conversion of existing customers to hydrogen, but there's opportunities for other technologies to take place as well in this road to decarbonisation. So what are we doing? Proving the case for hydrogen is one of our key objectives. It's now a national programme looking at the technical viability and the safety of transporting hydrogen within the network. So our pathway for decarbonisation is a national joint undertaking now through the Energy Networks Association and their Gas Grows Green initiative, where we're developing a number of products that will show the role for gas and certainly hydrogen in the future. There's a national evidence base that we're working with BEIS on that involves both Scottish Government and the UK Government developing again that transition from natural gas to hydrogen. And there's a number of key projects that either have happened or are in flight just now. So our Oban project looked at the changes to gas quality, high deploy, that Cadent gas are looking at for the blending of up to 20% hydrogen with natural gas. Future billing, a key one for consumers. If you change gas quality, then that could impact on the actual energy that consumers receive. And also, I mentioned H21, which is the project that Northern Gas Network are working on, looking at network features with hydrogen. And one of the other critical ones that Nigel has mentioned is our H105 project, which I'll come on to in a couple of slides. So there is a national programme of projects that are being developed in our next price control period, which has started this April and ends in 2026. So we've got a number of projects looking at our high pressure pipeline system, the LTS, looking at multiple occupancy buildings, again, very predominant in Scotland and other parts of the UK, and also the other gas networks, the National Transmission System are looking at their options for converting the high pressure pipelines to either transport a blend or 100% hydrogen. I'll quickly skip through this. Again, a number of other presenters have touched on this, the kind of the applications that are actually coming to the forefront with hydrogen. And it's interesting that, if we convert the gas network to transport 100% hydrogen, then it opens up a lot more opportunities to supply other vectors where we've not done that before with natural gas. So actually hydrogen is a game changer. And using the gas network, that just makes it a little bit easier to take hydrogen to a wider range of uses. So what have we done? We've actually carried out a lot of the early evidence gathering and development of risk assessments, both offline in laboratories, or as Ed mentioned, using some of the facilities such as the HSL have at their facility in Buxton. So we've tested looking at odorant within the gas network using hydrogen. We've looked at the consequence testing of materials with hydrogen. metering, and working with a number of the other initiatives that are on the go at the moment. So the High for Heat programme that was funded from BASE, which was looking at predominantly the downstream application of 100% hydrogen with appliances, and also, as I've mentioned before, the H21 project, which was looking at network features. And aligned with this, there's some of the commercial and regulatory development as well that we've undertaken as part of this early research work. And we certainly would do this all offline rather than, we would never test this with real customers, which is where we are now, heading into our H100 project, which will be the first end-to-end demonstration of 100% hydrogen within a gas network. So really, this project will inform the hydrogen system transformation. It has the opportunity to validate roughly 80% of the 280,000 kilometres of network material, components and construction across certainly the UK. And really, it's all about as well quantifying and qualifying customer and social acceptance of hydrogen for heat in a real world situation. And we will certainly be working with the local authority through H100, the consumers, and the project itself will hopefully be a statistical representation of those consumers and how they use hydrogen within their properties. The project, it will be from an offshore wind turbine producing electricity to produce hydrogen from an on-site electrolyser. We will have on-site storage, where that will help with security of supply during peak times. There will be other on-site injection facilities for the hydrogen into the network. We'll lay approximately 8 kilometres of new polyethylene pipe in parallel with the existing natural gas system we have in place already. And there will also be a demonstration facility built to ensure that customers can see hydrogen appliances in a real life situation. This is a voluntary project, so customers will be asked to sign up to the project, and we're looking for roughly about 300 consumers to take part over the period of the project itself. Future phases and expansion opportunities for H100, as I say, the initial projects for 300 properties. Future phases, we're looking to increase that to approximately 1,000 and look at the conversion of the network. As I said previously, we were laying a brand new 100% hydrogen network for the first phase, but future phases we'll be looking at conversion. We'll look at industrial commercial opportunities as well to bring on board some of the larger consumers, and also take into account those other vectors such as transport in the region as well. And we are really taking a whole system approach to this and tying in with some of our other projects that I'll mention in a couple of slides. So I did talk about, we are looking at our high pressure pipelines, so we've already done quite a bit of work. Again, looking at feasibility of converting the high pressure steel pipelines to hydrogen. And from a distribution perspective, that looks like a viable option. Again, I'm not going to go through all these steps. You'll see them in the slides when they're circulated after the event. But our next kind of step towards verifying the offline work is actually to test a section of pipeline that we own and operate between Grangemouth and Edinburgh, which actually is currently filled with nitrogen, but we can actually use that to test the transportation of 100% hydrogen in that steel pipeline. Other work we're doing, our East Coast Hydrogen project, and this ties in again with some of the other projects that are ongoing and you'll hear from later. So the Acorn project up in St Fergus, we are looking to actually start to build a new hydrogen pipeline from St Fergus, initially phase 1 down to Aberdeen, and then look at the conversion of the Aberdeen city. Phase 2 will be a new pipeline in the central belt, and then phase 3 is tying in those two elements from phase 1 and 2 to join that up to produce a hydrogen pipeline that will serve the majority of the major cities in Scotland, and again linking into the west coast as well. And this is really around us. Our strategy is to help the Scottish Government to meet that 2030 target. It's ambitious, but we feel that it is possible to actually have this constructed in time to help meet those targets. A couple of other areas we're looking at, as mentioned before in other presentations, the storage is a critical aspect of hydrogen. It's not a naturally forming gas, so therefore during its production we will start looking at storage. And we've got a number of projects on the go. One on this high scale, which is looking at the storage of hydrogen through either ammonia or the LOHCs. But we've also looked at the potential for geological storage of hydrogen through either salt caverns or through porous rocks. So we're working in conjunction with Edinburgh University and their geosciences department, looking at aspects of that storage, which we'll need as the market increases for hydrogen and that seasonal need for security of supply. And I thought it just worthwhile mentioning, obviously there's a lot going on in Scotland, but obviously with our southern network, we're looking at an industrial cluster around the Southampton area, again from the production of hydrogen with SMR or ATR, so methane reformation, carbon capture and storage, and then using that hydrogen in that industrial cluster setting, but with the view that that hydrogen could actually be transported around our network to major cities such as Portsmouth and Southampton, and again the wider use within other vectors such as transport. So that project is just finalising the initial feasibility study, and we'll be moving into early feed to take that one forward. And you know, our view is that it is about a whole system, whether that's you know, gas, electricity, but also, as I've mentioned, it's the other vectors as well. So looking at transport, looking at industry, and looking at heat networks as opportunities for that whole energy system, and how we as a network can support the increase in renewables from electricity generation as well. And we've recently just signed a charter with the electricity operators in Scotland, looking at how we can be more collaborative and work together around that whole energy system. So that was it from me. So thank you very much for your time.
Thank you very much, Colin. May I take this opportunity to ask anybody that has got a burning question to pop the question into the chat box. As mentioned earlier, Joe Pasiti, the Managing Director of CeeD, will farm out the questions to the panelists a bit later on. So please put your questions, pop those into the chat box. That's great. Moving back to Ed, and he's going to be talking about the whole system approach. So very much dovetailing in with what Colin was mentioning, and Joanne Allday, Strategic Business Development Manager for Port of Cromarty, Firth, is going to share a couple of slides as well. So over to you, Ed and Joanne.
In a sec, I'll just, I'm still seeing Colin, so I think Colin needs to stop sharing and then I'll be able to show my slide.
Yeah, unfortunately, I can't see the controls now on my screen. So
That's okay.
oh, that's better.
Okay, there
Yeah,
you
thanks,
go.
David.
There you go. Well done.
I've just taken you off.
Okay. So you see my slide okay, David?
Yeah.
Yes, we can. Yes, we can.
Fantastic. Okay, so there was I'll try and be as quick as I can and give Joanne plenty of time to describe the Cromarty stuff. So Colin used a phrase which we'll hear an awful lot, and it's coming out as this whole systems approach. So I'm going to very quickly try and cover what that means so people can put it in context, and we'll just run through it as quickly as you can. So what are whole systems? Why do we care? How, when, where, and by who, and some resources to follow up on. So whole systems, first off, what do we mean by a system? So it's the discrete elements and the interfaces between them. So it's an active and dynamic relationship. So what are whole systems? There's a whole lot of definitions, but one is it the vehicle, or is it the vehicle and the refueling systems, or is it the vehicle, the refueling systems, and the regulatory regime? You can define them in a number of different ways. So it's complicated, but actually there's a better phrase which is complex. Now, complex and complicated aren't the same thing. Complex is a particular type of system, and there's associated behaviors with that, which can be really useful and we can leverage. But broadly speaking, it means we're looking at all of the system elements for all of the system life cycle. So important concepts for whole systems are, so complexity. And what does this mean? So we have a mess. We have lots of different elements and interfaces, including with external things. There's internal structures to our systems. System of systems is a phrase that's often used. And we have system elements that are complex in their own right. So we're looking at automation. So we're talking about smart metering and our energy systems, this kind of thing. And also the boundary of the system, or rather the system of interest, can be hard to define, and it can be a bit arbitrary, and it's quite often porous. There's loads of interfaces across that boundary. But one really important concept, or two really important concepts from whole systems about being complex, is we have this idea of emergence. So the phrase, the sum of the whole is greater than the parts. And these emergent capabilities come from this interaction between elements. So it's leveraging this benefit you get from integrating and operating elements together. So for example, the gas network and the electricity network, the gas network provides not just a transport means, but also an energy storage means through line pack. So we start to have these capabilities, and if you combine that with electricity as well, you have these emergent benefits that you don't have with individual items by themselves. But the other really important thing is this idea of nonlinear behavior. You don't necessarily get the same output from the input you put in. So emergence and nonlinearity are two really important concepts for complex systems, which whole systems are. So why do we care? A lot of the features we want, or the capabilities we want, are actually emergent capabilities. So safety, security, availability, integrity, usability, and other T's. These are all things that I'll mention, but really they're emergent characteristics that we want. So we need to design for them. We can't just hope they're going to happen. So they emerge from the totality of the different elements and their interactions. So it's the difference between I want a car with I want to be able to travel between two locations at a time I decide. And that opens up possibilities for different solutions, trying to get away from the specific technologies, the capabilities you want. And that opens up the opportunity to look at alternatives and different ways of doing things. And so the flip side to that, I'm talking as a safety engineer, is often the problems we get also are emergent. So a lot of the safety issues and concerns we get. So we get benefits, we also get these issues that arise. So a good example is being traffic jams. And why is this, again, why is this important? So for complex systems, often if we haven't properly considered all the life cycle aspects of it and all the different aspects of the system, we miss requirements early on. And that can present huge sort of project risks and deployment risks. If you've missed these early requirements but not thinking things properly right at the start, you're probably already off track. But there are benefits to doing it as well. So I'll go back to the example of Korea. So I had the accident, but again, a lot of the concerns really are to do with the wider safety management concerns and through life maintenance and the commercial pressures where they were to get this work done. So it's not just about the immediate technological or proximate causes of those accidents. It's the wider concerns. It's taking this broader, more holistic view, helps us to avoid potential risks in the future. And just to put this in context, there's some resources. Again, these are hyperlinked. So CBOC, which is the System Engineering Body of Knowledge, in COSI, which is the International Council on Systems Engineering. There's a UK branch, some really useful resources and links to a whole lot of people. There's actually the COSI Energy Systems Interest Group. The current chair of that is based in Scotland, works for the Offshore Renewable Energy Catapult. So get in touch with the ESIG. I sit in the ESIG as well. SGN are on there. A whole lot of the people you're seeing and a whole lot of attendees are on there, but a really good body of people who are focusing on this broad area, and a number of other links for you to go to. And I will stop sharing and hand it over to Joanne, who will give a good example of integration of whole systems approaches in Cromarty.
Thanks very much, Ed. I will try and be as speedy as I can, and then everybody has a chance to hear from Jack and get their questions in. So you'll be pleased to know I only have 2 slides, and this, for those of you who are not aware of Port of Cromarty Firth, this is our facilities in Invergordon. The towers you can see at the front are for the Moray East offshore wind farm, and just behind those in Queenstock is the Kincardine floating wind farm demonstrator unit. So she's just about 2 megawatt units. You'll see a lot of the oil rigs in the background. That's what we've been known for the past 40 years. We do a lot of inspection, repair and maintenance on the oil rigs, probably one of the best places in Europe to do that. So, but we're not here to talk about oil rigs, we're here to talk about hydrogen. So this is our master plan for the North of Scotland hydrogen programme, which is a series of projects. And hopefully it demonstrates an example of a whole system approach for you. So we are looking at taking electricity from onshore and or offshore wind. We have a lot of grid constraint issues in the north of Scotland in particular, so it resolves some of those challenges for the developers. We are initially looking at a distilleries project, so it would be to bring that electricity onshore to a large-scale electrolyser. Our partners in that project include Scottish Power and Pale Blue Dot, and Jack is going to give you a little bit more information on the project later, so don't worry Jack, I'm not going to steal your thunder. We also have 3 distillery partners in that project, which is Glenmorangie, White and Mackay and Diageo, and we think the distillers will probably be amongst some of the first industrial users of that green hydrogen. And I should stipulate, actually, our project will be green hydrogen from the start. It's being designed that way. We're not interested in any of the other forms of hydrogen. So we are looking at creating our own green hydrogen on shore. We're also looking at security of supply through other projects. There's a number of people interested in developing projects in the Highlands, and we will also hopefully become a shipment hub and an export hub in the future. In terms of transport, we're working alongside the H3 project, which is a hydrogen refueling infrastructure project connecting Aberdeen and Invergordon. We're also working with NS HIMAP on a working group with regards to fueling vessels and bunkering vessels using hydrogen, working in partnership across the whole of the North Sea. It obviously makes sense to standardise on these things internationally. From a grid point of view, a heat point of view, obviously we're working with SGN. We're in a really strategic position right at the end of the gas grid, so it's there's an opportunity to decarbonise the gas grid and to move to 100% hydrogen from the Invergordon and the Conan Bridge end of that gas network, and that connects into some of the pan-European pipelines. From an export point of view, we've been working with ERM and also Oil and Gas Technology Centre and Martin's team on the bulk marine transport of hydrogen and what is involved there, in terms again of standardisation, the different types of carriers, and that study is just coming to its conclusion now. We also have a hydrogen working group which has now about 40 members, and we're looking at quantifying the demand to really make sure that we benefit from the economies of scale for this onshore electrolyser so that we can get the price of green hydrogen as competitive as possible. That working group is also keeping UK stakeholders informed of the different projects involved under this master plan, and it integrates local content from the start. So we see that there's a real opportunity to keep everybody involved and hopefully design the green hydrogen sector in a way that we bake in that local content from the beginning. And the final thing I wanted to mention is the Powerhouse, which is a research and development and education and skills centre. We hope it's going to be a global centre of excellence for both green hydrogen and floating offshore wind. And we're working in partnership with a number of academics and industry partners on that project, and it will be hosted by the University of the Highlands and Islands. So hopefully it gives you a sense of the whole system approach, but I am conscious of time, as I say, so I'm going to hand over to Jack to tell you a bit more about his projects, and then hopefully we will have some time to squeeze in some Q&A.
Thanks very much for the introduction, Joanne and Dave. I'll just share my screen. Great, hopefully that's coming through.
Yes, thanks, Jack.
Fantastic, thanks, Dave. And thanks for the invitation to speak today from yourself and CeeD as well. So the other speakers have given some really great context, and that will be very helpful for me to try and then go on to speak about two of the specific projects that we are developing at Pale Blue Dot. The two projects I'll be speaking about today are the Acorn Hydrogen project, and that is a blue hydrogen project based at St Fergus, and also the North of Scotland Hydrogen Programme, the distilleries project. And that is what Joanne touched on, and I can provide a bit more context in the next few slides. Before we dive into that, I thought I'd spend just a slide very briefly giving some scene setting and some background on the general move of the UK towards net zero and how that will impact in particular the power and energy sectors. So we can see on the left here the old normal, or how our energy systems used to work. We're obviously in this image highly reliant on fossil fuels, and whether that be gas, oil, or gas or oil. And these are used directly, both in industry and transport in the domestic sector, but also to produce power, and then that electricity is used. We can see a very small amount of renewable power also integrated in this system. And say in Scotland, we are somewhere in between these two images at the moment, having already moved away from coal from our power sector, and as Nigel highlighted, already doing quite well in utilising renewable electricity in the power market. But as we move over towards net zero, both Scotland and the UK have ambitions to enable net zero by 2045 and 2050 respectively. And for that to be realised, it will need a vast amount of new renewable electricity to be installed, whether that be onshore and offshore wind or solar power. And that can be used to directly displace the power that was originally from fossil fuels. It can also be used directly to electrify sectors of the economy which were reliant on fossil fuels previously. And it can also be used to produce green hydrogen. There's also currently with us highly reliant upon fossil fuels. And as we move towards net zero, that will have to stop being the case. We'll have to almost entirely remove the direct use of fossil fuels unabated. So that is, gas can still be used, but only in situations in which it's attached to CCS infrastructure, whether that be industry and CCS or hydrogen production, blue hydrogen and CCS. And that leads me to the first project I'm going to speak about today. That is the Acorn Hydrogen project. So this is Pale Blue Dot's flagship project and is part of the broader Acorn phases of work, which is the Acorn CCS project and the Acorn Hydrogen project, amongst other work. Pale Blue Dot are the lead developers on this project, but we're also joined by our partners, our industrial partners, Harbour Energy and Shell. And we've also received quite a bit of government support to get us to the stage from various sources, as can be seen on this image. But what is the project? So as I said, it's a blue hydrogen project that'll take natural gas from the UK continental shelf that's landed at St Fergus. St Fergus is currently the main landing point for natural gas in Scotland and lands about 35% of the UK's natural gas. So it's a really fantastic resource for natural gas being available. It's also fantastically well located for carbon capture and storage, and the North Sea that's accessible from St Fergus has a vast quantity of CO2 storage potential. So the project will be based at St Fergus and will take the natural gas and split it up into CO2 and hydrogen. The CO2 can then be captured and stored in the sister Acorn CCS project, and then the hydrogen has a couple of uses. For the first phase of the work, we're planning on injecting it into the national transmission system. So that would be at an initial 2% blend. And there's also a secondary route to market, which is supply of hydrogen to the Aberdeen city. And Colin described that very well in the Aberdeen Vision and the Northeast of Scotland work that he talked about before. And I have a slide in a few to give a bit more context on the Aberdeen Vision opportunity. So as I said, the first stage of the project will be a 200 megawatt reformer located at St Fergus, and this will be operational from the start of 2026. And two main routes to market, the blending into the NTS at a 2% blend and supply to Aberdeen Vision. And this will reduce UK emissions by about 400,000 tonnes of CO2 every year. And that will all be captured and stored through Acorn CCS. There's also a lot of opportunities to expand, and we're really excited about the opportunity to increase the level of reformers and hydrogen production at St Fergus. And that could be to supply increased levels of NTS blending, to supply increased amounts to Aberdeen Vision, amongst a number of other uses that we're considering. So the Aberdeen Vision project, Colin touched on this really well. This is a SGN project, and Pale supported them in the feasibility stage of this a number of months ago now. This looked at the opportunity to supply hydrogen into the Aberdeen city network. And to do this, there will be a new build dedicated hydrogen distribution pipeline installed from St Fergus that would connect into the Aberdeen network. As Colin mentioned, there's the opportunity to then expand this further. So we could start with an initial 20% blend of hydrogen. So the dedicated hydrogen pipeline would transport hydrogen, only hydrogen. And then at 2 or 3 locations within the existing Aberdeen network, this would be blended initially at a 20% blend by volume. And then there's the opportunity to expand that through to 100% blend as well. By the time we're at 100% blend in the Aberdeen network, there'll be about 1.16 million tonnes of CO2 per year saving. So very significant. And then that can be expanded, as Colin mentioned, using the same philosophy, potentially starting at a blend and moving through to 100%. So that was all I was going to say on the Acorn Hydrogen project. We've also got a second project underway. This one that I'll speak about is a green hydrogen project, and Joanne's already given a really great overview and introduction, which makes my job much easier. So we are just coming to the end of the feasibility stage for the distilleries project, which is part of the broader programme of work in the North of Scotland Hydrogen Programme. The project partners in this phase of work have been Scottish Power, ourselves, Pale Blue Dot, our 3 distillery partners, Glenmorangie, Whiteamakai and Diageo, and also Port of Cromarty, Firth. We've been very, very lucky and very excited to have those 3 distillery partners on board. It's made communicating with the end customer really easy, and it's been great to see their sort of enthusiasm. So I'm afraid you've already seen this graphic, but I can hopefully talk a little bit more around it and provide that bit more context. So the phase of work we've completed was looking to install an electrolyzer that would be around 25 to 40 megawatts in size, and that would be operational within 2024. We've currently identified 3 sites in the Cromarty Firth region that the electrolyzer could be located at, and all of them have a really great potential for build out and expansion. and that's a key part of this project. You know, to start in 2024, supplying the initial market, but then to look at all the amazing potential demands that might appear in the area and have the ability to expand the electrolyzer production to cater for those markets. So initially, as Joanne said, we'd looked at the distillery sector, and it's thought that those would be the initial baseload customers, which would take that demand in 2024. And then looking to expand quite significantly beyond that, whether that's to supply additional distillery customers, to supply that export market that Joanne talked about, with a huge amount of demand coming from Germany in particular, but other regions of Europe, but also to supply lots of other local cases, such as blending into the gas distribution network at Cromarty and Inverness, and potentially beyond. That is all from me, Dave. I'm very happy to pass back to yourself and handle any questions, or however you want to take it.
Thank you very much. Thanks very much, Jack. And that's great. And I see from the chat box, there's a few coming in. So I'm going to hand over in a few moments to Joe Pasiti, but thank you very much for all of the speakers this morning. I appreciate his time is just pressing on. So I'm going to hand immediately straight over to Joe.
Thanks, Dave. I know time is short. I think what we'll try and do, I see Joanne is certainly answering some of the questions that are coming in. We'll try and collect the questions and put the answers out. But one in particular, one from Ronald at Shivas, was actually asking about indicative numbers for a whole system losses, really to help look at the balance and the comparison between hydrogen or electricity. So I think from Shivas related to a distillery. So I guess the guys at Pale Blue Dot may have a broad answer for that one, if they can give them an idea of what the system losses are for hydrogen. Jack?
I guess that question is around efficiency of moving from electricity to hydrogen. I think Martin probably pulled up a slide earlier on, which had a good efficiency figure on it, and that's probably broadly similar to the one we're getting in our engagement with the electrolyzer manufacturers. So that's sort of around 70–75% efficiency of moving from electricity to hydrogen.
Okay.
I would also say it depends on what your application is. You know, it's saying taking this whole systems approach, like, well, is that an electricity system with interseasonal storage, or is it that it's quite a simple question. The answer is not necessarily that simple. And I think the reality is that we're going to end up with an awful lot of, there's a really good concept from systems engineering called requisite diversity, which is basically having the right tools for the right job. And so our future energy architecture is probably going to have a number of different solutions. And there are definitely areas of application that hydrogen isn't the right solution. And that doesn't, but it's not an either or, it's a both and.
I assume there's quite a lot of projects on demonstrators that are going to start to get that real world kind of analysis to kind of extrapolate out. So watch this space. I think the Green Distilleries Awards have got a lot of feasibility projects. There was another one from Kevin asking about the limitations as a fuel source for transport using hydrogen. I don't know who in the panel wants to put their hand up for that one and take that one on. So how do we look at hydrogen as a bigger step forward for trains, buses, and commercial transport?
I can probably Jack. I can put my viewpoint is that broadly it seems to be heavier goods are better for hydrogen. Heavier good sort of commercial good or commercial vehicles with batteries seems to be better for kind of personal transport. Marine sector's an interesting one, and they're kind of going. They've bet very heavily on ammonia, but that's partly so they can use the approach of carrying ammonia, but also using it as a fuel at the same time. So it's both a cargo and a fuel. And aviation, it's primarily the gaseous hydrogen is looking at kind of small regional aircraft. There's a real challenge for long distance with a hydrogen or potentially liquid hydrogen, or maybe actually, I think an awful lot of the aviation sector is saying actually synthetic fuels will be probably for long haul aircraft. Unfortunately, Jet A1, if you wanted to design a solution for high density energy storage for aircraft, it's kind of difficult to come up with a better solution. So synthetic fuels are probably going to be synthetic jet fuel is probably going to be what the long haul aircraft will move to, unless any other participants have got different viewpoints. But broadly, hand-wavingly, that's kind of where we are.
I think a question, we maybe have space for one, but Colin, I think this might be aimed at you, but the relative cost of hydrogen compared to gas, but projected maybe over the next 10 years. So I'm assuming that there's again, it goes back, there's a kind of crossover point. So do you have any kind of quick
happy to do that one, Joe. I mean, comparable, it should be very comparable, actually, or even less, are some of the projections that I've seen for the cost of hydrogen compared to natural gas. As you obviously stimulate the market, bring more producers online, the opportunities for dedicated offshore hydrogen production is certainly going to drive the cost down. Certainly for the demonstration projects, which will be a first of a kind, that you can't really compare the cost for what a consumer will pay at the moment with what they could pay in the future. But I think there was a question about producing hydrogen from using salt water. I think, again, Joanne's potentially answered some of that, but there's opportunities for desalination of seawater to produce hydrogen, as say, from offshore wind. And I think those demonstrations and projects will come along with like the ERM Dolphin project off Aberdeen. So we'll see the results of those, and that will give an indication again about the cost of production.
Dave, I'm conscious of time, so I know you're keeper of the watch. So what do you want to do? Do you want to carry on for a few more minutes, or
just a couple more questions? Just allow a little bit more.
Yeah, I mean, bearing in mind CeeD is an engineering and manufacturing network, one of the kind of points I'm kind of interested in is the supply and demand. And a few people have talked about the time scale. So when do you see that shifting? When do we see people producing product that are right for hydrogen and moving away from the engineering and solutions, if you like, for producing and storage and supply? So open to the panel. That might be one for Ed or Joanne, since you're investing a lot in the Cromarty Firth.
Right, Joanne, on to that one.
Yeah, thank you. So the different projects obviously are moving at different paces. Blue hydrogen is slightly better developed in Scotland. There's more projects in blue hydrogen. Green hydrogen is taking a little bit longer at scale, although obviously, as Nigel was saying, there's a lot happening in Orkney already. But I think we have to appreciate some of these things do take time, that they're not going to happen tomorrow. So we're looking at having green hydrogen available from 2023, which is actually very fast. But obviously there's a lot that has to be put in place before that, and there's funding requirements, there's engineering studies, there's design phases, etc. But all of that is opportunities for local content, for the supply chain. There's opportunities for people, for businesses, and what we're trying to do is build the sector in a different way than happened in offshore wind. So we got lots of local content in offshore wind, but I think we can all agree that we could have maybe done a bit better than we did. So if we can take that into account at this stage, then hopefully we can really increase the local content. And we do have a great opportunity in Scotland in that the industrial deployment of green hydrogen and floating offshore wind projects, for those sectors, we will be one of the first places in the world to be deploying those at commercial scale. So if we can make sure that local companies are aware of these sectors, aware of the developments, connected with the relevant decision makers, then hopefully they can build the technology and expertise that they can then export around the world as other countries decarbonise. But there is a caveat to that, of course. It's a global market. We've got to be competitive. We've got to have the best products. We're not going to be able to deliver everything. So we really need to focus on where are our strengths as a country and how do we make sure that we get in at the kind of ground level. And I've been trying to answer some questions on the side so that it's kind of kept the flow going, hopefully. But there are a number of different companies involved in developing new technologies, and I'm sure a lot of them are on the call. So if you are on the call and you've got these technologies, please put that in the chat as well, and make sure people are aware of what is happening in Scotland, because I've been amazed at what's already happening in hydrogen. It's really exciting, and I think there are massive opportunities for both people and businesses in the sector.
Yeah, I was going to say, I mean, a lot of the talk about energy, Colin, you might smile at this one, I guess, is about heat, but of course cooling, I think, is a bigger draw on energy around the world. So I guess the kind of heat pump interjection somewhere in there with hydrogen is a part of that mix, perhaps, to kind of tackle some of that as well. So you know, there may be other opportunities. Dave, are you still keen to?
Yeah, there's still 70 odd people on the
right.
call, so there's obviously an appetite to learn more, and I'm very conscious that I don't like to stop the discussion, because it's good to talk, in the phrase of the BT slogan. So if people are happy to carry on, then please feel free.
Yeah, one of the questions very specifically was, I suppose, the point that everything seems to be a little bit long term. So what about the short term opportunities, and are they still maybe a little bit focused on innovation, and should people keep their eyes open for demonstrator opportunities? I'm guessing government will be throwing money at some of these opportunities to see where they can go, or do people have some real commercial you know, points that they might want to flag up? So anyone on the panel might want to kind of pick that one up.
I mean, I can start that one off, Joe. I mean, I think from our perspective, you know, we've got the early demonstration projects, certainly with H105, but as I showed in my presentation, the construction of the pipeline down the east coast, I mean, we're going to actually start kicking off the pre-feed for that this year, in anticipation of actually starting construction probably around about 2024, 2025 for that first phase of that pipeline. And we've been quite fortunate in our, as I say, our new price control period has just started, and the allowances that Ofgem have provided to the regulated networks will be enough to, I think, kickstart a lot of these large-scale projects, either through the innovation funding that we're allowed, or through some of the reopener mechanisms that have been provided that will allow us to tap into larger pots of money to get these projects started.
I guess just adding to that from a developer side, we've obviously got the North Scotland Hydrogen Programme along Joanne, and you know, targeting first gas, you know, 2024, but there's opportunities to move that forward into 23. And so that's only 3 years away or less. So that's pretty close. And then also on the Acorn hydrogen side, targeting operation within 2026. And more generally, the government, the UK government, have got the BASE cluster sequencing work underway. And so they're aiming to have two clusters, two low carbon clusters operational within mid-2030s or mid-2020s, sorry. Again, fairly close term.
And I'd also emphasise it's not just UK or even Europe. So we're involved in 2 projects in Australia, one in Western Australia and one in Tasmania, which are both going to be fairly large scale and are, you know, entering that engineering design phase, and that's what we're supporting them on. So there's an awful lot of projects, that kind of 5-year window. There's an awful lot. There's been an awful lot of change, and we're currently at that phase where we're moving from R&D to early commercial demonstrator. So there's a lot going on, basically.
I know we're talking to Nigel about doing some joint projects and presentations shortly on transport, for example. But I guess maybe that's the plea, as Colin said, there's some in-flight activities, maybe bringing people back and sharing some of that in-flight activity will help give people confidence that there are short-term opportunities as well as the long-term opportunities. So we'll hold you to that, Dave, and the rest of the team will be knocking on your doors to get you back to do other things, I think, and whet the appetite and excite people to continue to kind of step forward. I'm just having a look through. I've got to look at the questions that are in there, Dave, as well, to try and find out what
My
we've missed.
apologies, I've got to head off for another meeting, but I think I said in the chat, I'm happy to,
Sure.
if you want to send me the questions offline, I'm happy to provide a response to all of them and at least run them past the other attendees as well to make sure that I'm talking sense. But I'm happy to do that outside of the meeting. So,
Yeah, I think
thanks very much for everyone, and it was really
Thanks,
good hearing
Ed.
everyone
Thanks,
else as
Ed.
well.
I think we'll take that opportunity now as we've gone almost 15 minutes over our time. So thank you very much, Joe, for facilitating that, and thanks Joanne and Jack and Neil and Nigel and everybody that's presented today. I'll get my tongue twisted in a minute trying to thank everybody. I'll go down the whole list, but without your contribution, without your knowledge, without the sharing of that passion that you have for this hydrogen area, we wouldn't be able to put this event on. So once again, thanks very much for everybody. And as I say, I'll be sending the slides out at a future time in the next couple of days. So once again, thanks very much and have a great day.